So as we add these smarts, we also have to add security around that. And that's what we do.
So we're at Sypris Electronics in Tampa, Florida, hard by Busch Gardens, but this facility has been here a lot longer than Busch Gardens has. And we're with Mike Duren and John Walsh. And we've talked a lot on this road trip about renewable energy and about the smart grid and obviously about the Chevy Volt. These guys are in the business of security, really, really serious security, and the electronics around security. And we're going to talk a little bit about what you guys are doing to ensure that the smart grid, which is being pounded every day by China and Russia and all those guys, stays secure. Welcome to the Drive for Innovation.
Thank you.
So tell us what you guys are doing.
Sypris is a company that for 48 years has been doing security for government, what we call high assurance applications, things where you need to make sure that the information within the architecture is not compromised. And Mike and his team have done an excellent job in looking at how to apply the same thinking and technology into securing the government's critical infrastructure. And to your point, as China and these other countries have been a growing threat to the national infrastructure, Mike and his team won a program with the Department of Energy to do just that.
So there's a lot of work going on to make the grid smarter. And a lot of people say this, the grid is already smart, and it is very smart. But as we add technology to help control it, to be able to accommodate higher loads of power in certain areas and shortages of power, there's a lot of new technologies that are coming online in the grid. That means they're accessible, or they can be reached through communications channels. So these new smarter devices, in some cases, bring more vulnerabilities or more exposure to the grid. They give a larger attack surface for an adversary to potentially exploit or to gain access to. So as we add these smarts, we also have to add security around that. And that's what we do. We're experienced in being able to provide high levels of assurance. With the smart grid, the stakes are higher. If someone were to gain access to the right device, or to be able to get into a part of the system that's a critical portion of the grid, there's a lot at stake. So there has to be a higher level of assurance applied to those applications than, say, what would be applied to your phone.
Right. So is we talking big box electronics, or Moore's Law has gotten it down to where you have amazing processing power to do the most sophisticated key encryption algorithms?
It's a very good question. I think that in some cases, well, in most cases, we're talking about small devices. But it's a big part of what we do is to try to miniaturize high assurance technologies. In fact, as the Department of Defense begins to deploy things like UAVs and other more mobile technologies, they also require high levels of assurance. And so we're well versed in being able to do that for devices that consume a small amount of power or that are very small.
I think another thing is that you're right on target. The technologies that we've traditionally used here have been very limited because they're high cost and they do take a relatively large footprint to deploy. And some of the things that Mike and his team have done is they've developed some disruptive technology that not only miniaturizes it, but substantially reduces the cost, so now we can use it in more commercial applications to solve these problems.
Utility companies don't like to spend an extra $10 or $20 on a meter, and they don't like to spend an extra $1. So we need to bring in technologies that don't cost a lot so they can be broadly deployed in things like that.
John, you were saying earlier that we're dealing with billions of nodes now, but with cars coming on the road, you can hack the Volt, you can hack other cars. You said it's going to be trillions in the not too distant future.
Right.
I can't even imagine how you try to find all the points of possible entry.
We have systems that look for, I'll call it defects, malware, attacks, and so you're very dependent on a probability to detect those types of intrusions. The technology Mike and the team are working on will make the system more independent and operate in the presence of a threat and won't be vulnerable to it. So it will make the architecture itself much more inherently secure, as opposed to trying to look for things and use firewalls to keep them out.
I think, Mike, you mentioned earlier you guys are working on a DOE program.
Yes.
Tell us a little bit more about that.
Right. So with our pedigree of building high assurance applications for the Department of Defense, we were able to convince the Department of Energy that we could apply the similar methods to secure portions of the smart grid. So we teamed with Purdue University and Oak Ridge National Lab and EPRI, which is the Electric Power Research Institute, to build key management systems for the smart grid. So as part of that effort, we're looking at deploying these technologies, these lower cost, these smaller technologies, and building a security system around those so that they can be deployed in the smart grid.
When you're working on a project like this, let's talk a little bit about the engineering involved. Is it a similar engineering cycle to your more traditional product lines, or does it take longer, twice as long, or because you're working with so many partners?
Well, I think that the engineering side of it is very similar. We use the same processes, we use the same types of resources or developers. So the engineering is very similar. I think one of the challenges that we face is the landscape of smart grid is very complex in terms of standardization, protocols, lack of standards in some cases. So identifying the requirements, identifying the best way to integrate with systems is really the biggest challenge. And that has a lot to do with just the fact that there's a lot of dynamics right now in the industry. Utilities are deploying things, but other folks, working groups, are still defining what it is to have a smart grid, yet alone to have a secure smart grid.
With the technology Mike and the team have developed, we have a way of doing things that is not only low cost, but it can be integrated into the legacy architecture without a lot of expense. We have to do the same thing in the DoD. In today's environment, there's a lot of focus on upgrading existing platforms to keep the budget and the cost down for the defense spending. So we're seeing a lot of pressure to reduce our costs, get new products to market quicker, upgrade platforms, and so time to market, doing it quickly, and making sure we can integrate with and be compatible with the legacy systems is probably a way to get them to adopt the technology earlier